Hello everyone, I am Prashant Kumar studying at Sri Venkateswara College of Engineering, Bangalore. Today we are going to discuss about basis path testing guidelines and observation from software testing subject module 3. Now having a look through the table of contents where we are going to discuss about basis path testing, McCabe's basis path method, essential complexity, guidelines and observation, and finally the conclusion. Introduction: Basis path testing is based on the cyclomatic complexity measure which quantifies the number of linearly independent paths through a program source code. It helps in identifying the minimum number of test cases which are needed to achieve a certain level of coverage. This method is particularly effective in detecting logical errors and ensuring comprehensive testing of all possible control flow scenarios within a program. Basis path testing is a structured testing methodology used in software engineering to ensure thorough testing of control flow in programs. It involves identifying the independent paths through a program source code and designing test cases that cover these paths to enhance test coverage. Basis path testing: the mathematical notation of basis has attractive possibilities for structural testing. Certain sets can have bases, and when they do, the basis has very important properties with respect to entire set. Mathematicians usually define a basis in terms of structure called a vector space, which is set of elements, as well as operations that corresponds to multiplication and addition defined for the vectors. If a half dozen other criteria apply, the structure is said to be vector space, and all vector spaces have a basis. The basis of vector space is a set of vectors that are independent of each other and span the entire vector space in the sense that any other vector in the space can be expressed in terms of the basis. A set of basis vectors somehow represents the essence of the full vector space. Everything else in the space can be expressed in terms of the basis, and if one of the basis element is deleted, this spanning property is lost. The potential application of this theory for testing is that if we can view a program as a vector space, then the basis for such a space would be a very interesting set of elements to test. If the basis was okay, then we could hope that everything that can be expressed in terms of the basis is also okay. In this section, we examine the early work of Thomas McCabe, who recognized this possibility in the mid 1970s. McCabe's basis path method. In this figure is taken from McCabe's 1982. It is directed graph that we might take to the program graph or the DD path graph of some program. For the convenience of the readers who have encountered this example elsewhere, McCabe's 1987, Perry 1987, the original notation for nodes and edges is repeated here. Notice that this is not a graph derived from structured program. Nodes B and C are a loop with two exits, and the edge from B to E is a branch into the if statement in nodes D, E, and F. The program does have a simple entry A and a single exit G. McCabe based his view of testing on a major result from graph theory, which states that the cyclomatic number of strongly connected graph is the number of linearly independent circuits in the graph. So here is a McCabe's control graph and derived strongly connected graph, which shows how the working of those graph has been done, how A, B, C, D, E, F, and G are connected linearly in order so as to possibly connect all the paths. Some confusion exists in the literature about the correct formula for cyclomatic complexity. Some sources give the formula as V of G, which is equals to E minus N plus P, while others use the formula V of G is equals to E minus N plus 2P. Everyone agrees that E is the number of edges, N is the number of nodes, and P is the number of connected regions. The confusion apparently comes from the transformation of an arbitrary directed graph to be strongly connected directed graph obtaining by adding one edge from the sink to the source node. Adding an edge clearly affects value of computed by the formula, but it should not affect the number of circuits which are counting or not counting the added edge. Accounts for change to the coefficient of P, the number of connected regions. Since P is usually 1, adding the extra edge means we move from 2P to P. So here is the simple formula about the McCabe's basis path method where V of G is equals to E minus N plus P. For example, 11 minus 7 plus 1 is equals to 5. So the cyclomatic complexity of the strongly connected graph, which is shown in the figure, thus there are 5 linearly independent circuits. If we now delete the added edge from node G to node A, these 5 circuits will become 5 linearly independent paths from node A to node G. In small graphs, we can visually identify independent paths. Here we identify paths as a sequence of nodes where P1 ABCG, P2 ABCB, CG, P3 ABEFG, P4 ADEFG, P5 ADFG. Observations. The two major soft spots occur in the MEC-CAPE wave. One is that testing the set of basis path is sufficient, and the other has to do with the yoga-like contortions we went through to make program paths look like a vector space. MEC-CAPE's example that the path ABCBCBCG is the linear combination where 2P2 minus P1 is very unsatisfactory. What does the 2P2 part mean? Execute path P2 twice. Even worse, what does the P1 part mean? Execute path P1 backward. Undo the most recent execution of P1. Do not do P1 next time. Mathematical sophistries like this are a real turnoff to practitioners which are looking for solutions to their very real problems. So as to get the better understanding of these problems, we will go to the triangle problem where we start off with the DD path graph triangle problem. So here are the points like P1, P6, P4 and P5 where the conditions must be satisfied. If A, B, C, E, F, H, J, K, M, N, O are lasting, then it is said to be scalene triangle. Or if it does not last, if it lasts with a O, then it is not a triangle. And if it satisfies all these conditions, then it's said to be scalene, not a triangle, equilateral, isosceles. So the triangle problem is a typical in that no loops occur. So the program has only 8 topological possible paths, and of these only 4 basis paths I have listed above are feasible. Thus for the special case we arrived the sum test cases as we did with special value testing and output range testing. Essential complexity. The basic idea is to look for graph of one of the structured programming constructs, collapse it with single nodes and can be found. This process is followed by the figure which starts with DD path graph of the pseudocode triangle problem. Then if then else constructing involves node B, C, D and E is condensed into node and then 3 if then constructs are condensed onto nodes B, C, D. The remaining if then else which is condensed into node E resulting in the condensed graph with cyclomatic complexity where V of G is equals to 1. So here are the structured programming constructs which shows sequence, pre-test loop, post-test loop by using the conditions if then else and switch cases. So violations of structured programming constructions figure is mentioned where branching into decision, branching out of decision, branching into a loop and branching out of a loop has been shown. Guidelines and observation. In our study of specification-based testing, we observed that gaps and redundancies can both exist and at the same time cannot be recognized. The problem was that specification-based testing removes us too far from the code. The part testing approaches to code-based testing represent the case where the pendulum has swung too far the other way, moving from code to directed graph representations and the program path formulations obscures important information that is present in the code, in particular the distinction between feasible and infeasible paths. Also, no form of code-based testing can reveal missing functionality that is specified in the requirements. Guidelines and observation. Path-based testing also provides us with a set of metrics that act as a cross-checks on specification-based testing. We can use these metrics to resolve the gaps and redundancies question. When we find that some program path is traversed by several functional test cases, we suspect that this is redundancy is not revealing new faults. When we fail to attain DD path coverage, we know that there are gaps in the functional test cases. As an example, suppose we have a program that contains extensive error handling and we test it with the boundary value test cases min, min plus, nominal, max minus and max plus. Because these are all the permissible value DD paths corresponding to the error handling code will not be traversed. If we had test cases derived from robustness testing branch into a decision. Beyond this, rather obvious use of coverage metrics and opportunity exists for real testing craftsmanship. Any of the coverage metrics in can operate in two ways. either as a blanket, mandated standard, or as a mechanism to selectively test portions of code more rigorously than others. We might choose multiple condition coverage for modules with complex logic, while those with extensive iteration might be tested in terms of loop coverage techniques. This is probably the best view of structural testing. Use of the properties of the source code to identify appropriate coverage metrics and then use this as a cross-check on functional test cases. When the desired coverage is not attained, follow interesting paths to identify additional test cases. Conclusion. In conclusion, basis part testing is a systematic approach that enhances the reliability and quality of software by ensuring thorough testing of control flow paths. By following established guidelines and leveraging its benefits, software teams can effectively identify and address potential issues early in the development lifecycle. Thank you.